And then the diamond ring is when that last stream of sunlight shines through the edge of the deepest valley on the edge of the moon, just before totality occurs. This is a good time to take your protective eyewear off and actually look at the sun. It's safe to look at the sun during totality, and to see the transition from the diamond ring to the corona is really spectacular. And by the way, this is a good day. If you're thinking about proposing, August 21 is a great day. I mean, when else can you give a girl 3 diamond rings for the price of 1, right? And then, of course, the sun's corona. This is the only opportunity in your lifetime that you will have to see the sun's corona. This is the tenuous outer atmosphere of the sun. We are actually part of the sun's outer atmosphere. So this idea of splendid isolation is a myth. I know the sun is 93 million miles away, but we are a participant in the activities of the solar system here on Earth. In fact, NASA is going to be doing some extensive studies of the solar corona during this eclipse. Because it's crossing the country, and because we have the technology to do it now, there are several experiments, including citizen experiments, that are going on to get footage of 92 minutes of the solar corona. But it's really a spectacular sight. You can see the moon here blocking out the photosphere of the sun. You can see the magnetic field lines and the prominences on the edge of the sun. It's really a spectacular view. Again, I just want to say, during the partial phases, you need to have protective eyewear. And everybody here tonight is going to have the opportunity to get some ISO-certified eclipse glasses. But when totality occurs, if you're in the path of totality, look at the sun. This, again, is something my astronomy professor really hammered home to us. It's safe to look at the sun during totality. You've only got a couple minutes, but it's your once-in-a-lifetime opportunity to see the solar corona. So when that moment of totality occurs, assuming you're in a place in the path where it's clear, it's going to be 2 minutes, roughly 2.5 minutes of the most spectacular natural phenomenon you're ever going to witness. Now, why do we even get an opportunity to see the solar corona? Interesting fact, and this is kind of a disturbing fact in the world of astronomy. It turns out that from our vantage point here on Earth, the sun and the moon appear to be exactly the same size in the night sky. Now, obviously the sun is much larger than the moon, 400 times, but it's also 400 times further away. So the reason why we see the eclipses that we do is because the ratio of the moon and the sun in our sky is exactly the same. And astronomers have been kind of mulling this over for years. Is it just a coincidence that the Earth and the moon, or that the sun and the moon are exactly the same size in our sky? Or is there something else? Turns out, I don't know what your belief is in life in outer space or not. There may be life out there, there may not be life out there. But we may be the only intelligent species in the entire universe that lives on a planet whose moon perfectly eclipses its sun during a total solar eclipse. We may be the only intelligent species in the cosmos that see these types of eclipses. And that gave us the opportunity as sentient beings to prove one of the most remarkable theories in all of science. Really the work of a madman, if you think about it. Einstein sits in his office for 8 years and dreams up relativity, general relativity. Gravity is not a force, it's a distortion of the fabric of space and time due to the presence of matter. How on earth do you prove that? Well, it turns out during a total solar eclipse, if the sun is warping the fabric of space-time, stars from behind the sun, their light should be bent in its path to Earth. Light only knows straight lines. How do you prove it? You can't look at it because the sun is too bright, but during a total solar eclipse, when the sun's light is blocked, you can actually measure the angle. And here you can see from Sky and Telescope, August of 2016, the angle that Newton's theory of gravity predicted and then Einstein's general theory of relativity predicted, which is almost twice as much. And sure enough, 1919, Sir Arthur Eddington made a trip to Principe off the coast of South Africa and observed a total solar eclipse. He took this image right here, he measured the starlight and the angle of deflection from the starlight and proved that Einstein's general theory of relativity was right. It's one of the rare times in science when a scientist comes up with a theory by first principles. Not empirical observations, not experimentation, just sitting in his lab, thinking it through, writing equations down, and he turned out to be right. Remarkable. And I love this quote right here. Stars not where they seem to be or were calculated, but nobody need to worry. In fact, there are going to be relativity tests during the August 21 eclipse. Universities are going to be reenacting Einstein's general theory of relativity and actually measuring the starlight. There's a Light Up in Sky and telescope on how to do this.